right, happy snow day. Here is your video for calculus. This is technically day 104. So we can label that. And today we're doing more log differentiation. And indefinite and definite integrals involving 1 over u. Kind of a long title today. All right, so we're going to start with some practice questions from the last couple days. The first one is going to be find y prime if y equals ln of x cubed radical 6x minus 5. Okay, so yesterday we were doing logarithmic differentiation near the end of class. This is just a regular old find the derivative. It's already an ln. So there's a couple ways to proceed. We could use chain rule twice, or what else could I do? Right, so I could use log properties and split this up. So this would become y equals 3 ln of x plus 1/2 ln of 6x minus 5 to start out with. So I used the power rule, brought the exponent out front. 2 logs, or 1 log multiplied is 2 logs added. Now I can find y prime a little easier. This would be 3 times ln of x derivative is 1 over x plus 1/2 times ln of 6x minus 5 would become 1 over 6x minus 5 times the derivative of 6x minus 5, which would just be 6. Do a little canceling there. The 2 is going to go away with a 6, leaves us with a 3. So I have y prime equals, this first piece is really 3 over x plus 3 over 6x minus 5. And remember, depending on if it's multiple choice, short answer, that's totally an acceptable way to leave it. But if it was multiple choice, maybe they'd rewrite this as one fraction. So we'd have to multiply the first fraction top and bottom by 6x minus 5. So what would that be? That would be, on top we'd have 18x minus 15 over x times 6x minus 5. Plus, I just multiply this by x, I have a 3x over that same denominator, x times 6x minus 5. And combining like terms, we'd end up with 21x minus 15 all over x times 6x minus 5. And I can't reduce that anymore. I could take a 3 out of the top, but that wouldn't cancel with anything. So that's probably the most simplified version. Okay, that's the first one. Number 2, also fairly straightforward. Find y prime if y equals ln of pi x. Okay, so it's another ln derivative. This one's a little bit easier. I could split this up if I wanted to, but this one's pretty easy just to take as is with a chain rule. Y equals 1 over pi x times, what's the derivative of pi x? Right, pi, because pi is just a constant. And then what's going to happen, those pi's cancel, I'm left with just 1 over x. You could have also split that up like we did the first one, ln of pi plus ln of x, but ln of pi is a constant, so that derivative would have been 0. Derivative of ln of x is 1 over x. We would have gotten the same thing. Okay, so that's those two. Now I want to do a logarithmic differentiation question. So we were doing this near the end of class yesterday. We did a couple examples. This one I'm going to say use logarithmic differentiation to find dy over dx. And we're going to do two of these. The first one will be y equals x to the 4x squared. Now, does anyone remember why this is a perfect candidate for logarithmic differentiation? It's because there's an x in the base and the exponent, right here and right here. So whenever that happens, logarithmic differentiation is really the only way to proceed. So start by taking the ln of both sides. So ln of y equals ln of x to the 4x squared. Now, why did we do that? Because anytime I have a log with an exponent, I can bring that exponent out front. So this is ln of y equals 4x squared times ln of x. Now our goal is to find dy dx, so I can take the derivative now, implicitly. Derivative of ln of y is 1 over y dy dx. And that's going to equal, what do I have to use over here? Product rule. So first times derivative of the second plus the second times the derivative of the first. Can clean this up a little bit. We get 1 over y dy dx equals, that's going to cancel with one of those, so just 4x plus 8x ln of x. Remember, our goal is to solve for dy dx, so I want to get this piece alone. So how would I do that? Multiply both sides by y. So now I have dy dx equals y times 4x plus 8x ln of x. Now remember, I don't want that y in my answer because I don't want x's and y's. That looks ugly. So what is y really? Well, y is x to the 4x squared. So I plug that back in. So we've got dy over dx equals x to the 4x squared times 4x plus 8x ln of x. Okay, so we've solved for dy dx. That is our answer, and a totally appropriate answer if it's short answer, but if it's multiple choice, what crazy stuff could they do? Well, for one thing, they could take a GCF of 4x out of here. So this is the same as saying x to the 4x squared times 4x times 1 plus 2 ln of x. All right, do you think we could do any more? Well, we actually can, because here I'm multiplying two expressions with a common base. This is x to the first. So when I'm multiplying things with a common base, what do I do with the exponents? We can add them. So this would actually be 4x to the 4x squared plus 1 times 1 plus 2 ln of x. And if they wanted to get real crazy, they could also just say that this is 4x to the 4x squared plus 1 times 1 plus ln of x squared. So I take you through all that just to show you all the different ways that they could write this answer. So there's lots of options. Any of them are acceptable, but just be able to recognize them if it's multiple choice. Okay, let's do one more logarithmic differentiation before I get to the new stuff. Any questions? Don't see any hands, so let's keep going. Okay, so second logarithmic differentiation question. Let's find the derivative or find dy dx of y equals x minus 2 squared over radical x squared plus 1. All right, so again, we don't have to use logarithmic differentiation with this. We could use quotient rule, but it'd be an ugly quotient rule because you got quotient rule, you got a couple chain rules going on there, radicals involved. Pretty ugly. Not that logarithmic differentiation isn't going to be much better, but let's just try it. If I take the ln of both sides, we get this. I gotta use log properties on the right, so let's make this look a little cleaner. Ln of y equals, this will be, the top will be 2 ln of x minus 2. 2 comes out front. We're dividing, so minus, what's going to be out front here? 1/2 ln of x squared plus 1. Next step, take the derivative implicitly, so this becomes 1 over y dy dx equals 2 times 1 over x minus 2, technically times 1, because the derivative of x minus 2 is just 1, minus 1/2 times 1 over x squared plus 1, times the derivative of x squared plus 1, which is 2x. And cancel that 2 with that 2. Okay, so now I have 1 over y dy dx equals 2 over x minus 2 minus 1, well, actually minus 1x. So let's say minus x over x squared plus 1. Multiply by y. And then we get dy dx equals, that y's out front, but let's put in what y actually is. That blue radical, or x minus 2 squared over radical x squared plus 1. So sub that in, x minus 2 squared over radical x squared plus 1 times 2 over x minus 2 minus x over x squared plus 1. Now, could I do more to that? Sure, we could distribute, we could get common denominators. Not going to look all that much nicer. So for this one, I'm just going to leave it there. But know that the AP could do some nasty stuff, and they could keep doing some algebra to that. Okay, so that's a quick review of what we did the last couple days. Now, the new stuff I want to talk about is some integrals involving 1 over u. So I'm going to get to a clean page. You can keep going on this page if you've still got room. But I'll flip over. Here we go. Okay. So we're going to start with indefinite integrals. So let's say I had the integral of 1 over u du. We'd be thinking, what do I know that if I take the derivative, I get 1 over u? You should all be saying ln of u. But since it's indefinite, plus c. Okay, now that should make some of you a little bit uncomfortable, because depending on what u is, we could have an issue. So this is only good if u is a positive function. Or, yeah, if u is a positive function. Why would it be a problem if it wasn't positive? Because you can't take the log of a negative or 0. So, but if u is negative for any x values, we must negate it. Because you can't take a negative ln. If it's 0, there's nothing we can do at all. But at least if it's negative, we can negate it. So, in that case, the integral of 1 over u du would be ln of negative u plus c. So to avoid having to worry about this crazy positive or negative thing, we usually just take the absolute value. And then it works every time. So to avoid having to think about positive or negative, we just say that the integral of 1 over u du is equal to ln of the absolute value of u plus c. And that's what we're always going to use. All right, so I got 3 indefinite integrals I want to evaluate using this as practice. So for all these examples, we're just saying evaluate. So number 1, I want to evaluate the integral of 1 over 2x minus 1 dx. So it's not just 1 over x, so it's not just ln of absolute value of x. We're going to have to deal with this function down here. So this is a u sub question. Keep that right there. Okay. So I'd have to say, what do you think I'd have to let u equal? Well, u is that piece in the denominator, so 2x minus 1. So that means that du over dx is just 2. And I'm looking to solve for dx. I'm going to have to put that in. Remember how we do u sub? So to get dx alone, I'd end up with du over 2 equals dx. Okay, so now I can sub in. We've got the integral of 1 over u times du over 2, which is the same as just pulling the 1/2 from the over 2 out front. So 1/2 times the integral of 1 over u du, which would be 1/2 ln absolute value of u plus c. And my final answer, plugging in u again, would be 1/2 ln absolute value of 2x minus 1 plus c. Remember, you can always check an integral by taking the derivative. So if you take the derivative of that, you should get 1 over 2x minus 1. And you do. Okay, let's go on to try the second one. Number 2, the integral of x squared over 4 minus x cubed dx. Now you can recognize this as being some sort of ln probably because of a larger exponent in the denominator, which means that it's a good u sub candidate, but when I take the derivative of 3x or x cubed, I get 3x squared, which means I get the piece that I need, but u is going to have to be in the denominator because I need the derivative of x cubed to get that other piece. So we would say let u equal 4 minus x cubed, which means du over dx would equal what? Negative 3x squared. I'm looking to solve for x squared dx. So can you see that if I get du divided by negative 3 equals x squared dx, is it okay if I skip a step like that? So I divide the negative 3 over, at the same time I multiply by dx. There's that x squared dx that I need. So this integral becomes, I'm going to put 1 over u, and x squared dx is times du over negative 3. So I can pull that negative 1/3 out front, times the integral of 1 over u du again. And that becomes negative 1/3 ln absolute value of u, don't forget absolute value, plus c, and then plug in u. Negative 1/3 ln absolute value of 4 minus x cubed plus c. And there you go. And again, if you're ever doubting what you got, take the derivative, see if it gets x squared over 4 minus x cubed. It will. Okay, I want to do one more indefinite integral and then end with a couple definite integrals. So number 3, the integral of 1 over x ln of x dx. So this still is a good u sub question, because if I can take the derivative of one piece and get the leftover piece, then we're good to go. What do you think I'd want to make u this time? What could I take the derivative of that would still have the other piece in it? Hopefully you're saying let u equal ln of x, because the derivative of ln of x is right here, 1 over x. So if I say that du over dx is 1 over x, we have that other piece. We have 1 over x dx. So du is exactly what I need, 1 over x dx. So if you need to see this, this is really the integral of 1 over x times 1 over ln of x times dx. Can you see how that's the same thing? Normally I wouldn't write that. But then you can see if I put in the integral of 1 over u for ln of x, and then 1 over x times dx is just du. So then the integral of 1 over u is ln of the absolute value of u plus c. Then all I have to do is plug in u. So it looks a little weird, but it's the ln of the absolute value of the ln of x plus c. And I think if you think about it for a second, if you try that out, you'd see that the derivative is exactly what we started with. Okay, any questions? If you do, send me an email, or we can talk quick at the beginning of class, next class. But moving on, I want to do a couple definite integrals. Okay, and these basically are the same idea, just we have bounds now. So I want to do, we'll start with an easy one, the integral from 1 to 2 of 1 over x dx. Okay, so we don't even need u sub with this one. This is as easy as it gets. This is just ln of the absolute value of x, and that no longer plus c, because we are evaluating from 1 to 2. So this would be ln of 2 minus ln of 1. But I should never see log or ln's of 1 anywhere, because what is ln of 1? Right, log of 1 is always 0. So get used to that, because that's going to come up a ton. Anytime you got a 1 inside an ln, that whole piece is just 0. So the answer is just ln of 2. Now, if you need a quick explanation why that is, why is the ln of 1 0? Well, because ln is really log base e, and log means e to what power equals 1. Well, anything to the 0 power equals 1. That's why log of 1s are always 0, because the power is the answer to the log. Okay, now let's end with a little crazy one. We'll do more definite integrals some other day. But to end with, let's talk about the integral of tangent of x dx. What is the integral of tangent of x? Well, I know the derivative of tangent of x is secant squared, but that doesn't necessarily tell me anything about the integral of tangent. So let's derive the rule. So hopefully you could all believe that the integral of tangent of x dx is the same as the integral of sine of x over cosine of x dx. And then can you see how this could be a good u sub candidate? Because the derivative of sine is cosine, the derivative of cosine is negative sine. The question is, what do we want to make u? Well, you actually can't make u sine, because even though the derivative of sine is cosine, the leftover piece wouldn't really be cosine here, it'd be 1 over cosine. But if I let u equal cosine, the derivative is negative sine, and sine is the important part that is left over. So we're going to say let u equal cosine of x. So then du over dx, derivative cosine is negative sine of x. So if I'm looking for sine of x dx as my substitution, then this is going to have to equal negative du, or du over negative 1, either way. Okay, so are you okay with me saying this is equal to the negative integral of 1 over u du? I pulled the negative out front from the du, which is sine of x dx. And since u is cosine, and I took out sine of x dx, I'm left with a 1 on top and the u on the bottom. So then this is just the negative ln of the absolute value of u plus c. So that means that the integral of tangent of x dx is negative ln of the absolute value of cosine of x plus c. So that's the integral of tangent. But, you know how I love this, I could also write this a different way. This negative out front really means what? It's like negative 1. So when there's a number out front of a log, what can you do? You can put it in. So this would be ln of the absolute value of cosine of x to the negative 1 plus c, which is the same as saying ln of the absolute value of 1 over cosine of x plus c. So another way to write this would be the positive ln of the absolute value of, what's 1 over cosine? Secant of x plus c. So that is how you would do the integral of tangent. And that's not one that I have memorized. That's one that I probably would derive just like that if I ever needed it. All right, so that's the end of the notes. And homework-wise, what I will be assigning that will be due at the end of next week from this, from what we just did, you can do problem set number 98, which is some book work. And you can also do, problem set number 99, which is a few questions off of worksheet 7.2. So I haven't handed out 7.2 yet. I'll send you all an email with that attached if you want to start working on it this weekend. I'll hand you out a real copy of it on Monday, but those two problem sets along with problem set 97 are what's currently going to be due next week. All right, if you got any questions on anything we went over in this video, just make a note of it and ask me at the start of class when we come back to school. Otherwise, good luck.